Hello everyone. Continuing numerical methods, in the previous session we saw how we can solve an interpolation problem using Newton forward difference formula. In today's session we will look into one more problem of interpolation, and we will just check which interpolation formula can be applied to that, right? So the problem is the distance traveled by a point P in xy plane in a mechanism given by y in the following table. Okay, the mechanism is given by y. The distance traveled by point P in an xy plane, and the way it traveled is given by y in this data table. Okay, the second row, right? Estimate the distance traveled by P when x is equal to 4.5, and the data table is x values with 1, 2, 3, 4, 5, y values 14 for 1, 30 for 2, 62 for 3, 116 for 4, and 198 for 5. Of course, the first thing which we need to check here is the interval is equal spaced. And of course, 2 minus 1, 3 minus 2, 4 minus 3, 5 minus 4. The difference is 1, so h value is 1. Next to that, we will just write the same data table in vertical way, and we will just see, of course, as you know, here x naught is 1, the corresponding value of y is y naught. Similarly, you have x1, x2, x3, and the last value is taken as xn. Okay, in the same way, the corresponding values are written as y1, y2, y3. Corresponding value of xn is yn. We have been told to find at x is equal to 4.5, so we will be taking xp to be equal to 4.5. It is easily visible that 4.5 is nearer to xn, right? In the earlier case, we had the point xp was nearer to x naught, but this one is nearer to, the xp is nearer to xn. Okay, so with this we will write the conclusion. Here xp is 4.5, which lies near xn, which is equal to 5. Therefore, we construct backward difference table here. If it was nearer to x naught, we would have constructed forward difference table. Alright. Of course, here backward difference table is giving us this result. Okay, and I don't elaborate much on this. We have already discussed the construction of finite difference table and converting that to forward difference or backward difference in the previous sessions. Okay, please check into that. And in the next stage, the last values, yn is 198, del yn is 82, del square yn is 28, del cube yn is 6, and finally del power 4 yn is 0. Okay, we will just mention all those datas. So from the table we have, yes, all these 5 datas. It has to be observed that del power 4 yn is 0, right? Also, of course, we know xn is 5, h, the finite, the difference is 1, and xp is 4.5. So from Newton backward interpolation formula, we have yp to be equal to yn plus p into del yn plus p into p plus 1 divided by 2 factorial into del square yn plus p into p plus 1 into p plus 2 divided by 3 factorial with del cube yn plus p into p plus 1 into p plus 2 into p plus 3 divided by 4 factorial into del power 4 yn. And as we already know, del power 4 yn, the value is 0. So we can directly substitute 0 there, and we need not write it in a elaborated way. The next stage, here we know P, in backward interpolation, P is given by xp minus xn divided by h. xp value is 4.5, xn is 5 divided by 1, Of course, the difference is minus 0.5. So here p-value is minus 0.5. Once we find all the values, we will be substituting it. So here yn is 198 plus p-value is minus 0.5 into del yn is 82 plus p-value is minus 0.5 in the numerator into p plus 1 is minus 0.5 plus 1 divided by 2 factorial into del square yn is 28. Next to that, yes, in the numerator we have minus 0.5, the p-value, minus 0.5 plus 1, which is p plus 1, minus 0.5 plus 2, which is p plus 2, divided by 3 factorial into 6, which is del cube yn. And the last value, as we know, del power 4 yn is 0, we will directly mention it as 0, right? Now simplifying a little, we already know like 2 factorial is 2, 3 factorial is 6, so the denominator is changing, and same time minus 0.5 plus 1 gives us 0.5 and minus 0.5 plus 2 gives us 1.5. So substituting all this, now we will multiply and simplify, and we got 198 minus 41 minus 3.5 minus 0.375. The value of that is 153.125. Therefore, yp, which is equal to f of xp, which is equal to f of 4.5, is equal to 153.125. Therefore, the distance travelled by p when x is equal to 4.5 is 153.125 by backward interpolation. If the point which has to be found lies near the last value xn, then we will consider backward interpolation. If it is lying near the initial point x0, then we will consider forward interpolation. Okay? So this thing we need to keep in mind. That's all for today. We will look into some more important problems in the upcoming sessions. Thank you.